Hi everyone, this is Miss Graham, and today we are looking at lesson 12-1, slope-intercept form. So go ahead and pull out your physical or digital textbook to page 175. Our learning targets for today are we're going to write equations of a line in slope-intercept form, and we're going to use slope-intercept form to solve problems. So a lot of what we're looking at today builds off of our last unit. Let's get started by reading this word problem that we have here. So when a diver descends in a lake or ocean, pressure is produced by the weight of the water on the diver. As a diver swims deeper into the water, the pressure on the diver's body increases at a rate of about 1 atmosphere of pressure per 10 meters of depth. The table and graph below represent the total pressure, Y, on the diver given the depth, X, under water in meters. Let's go ahead and highlight some important pieces of information that we just read about. So we know we're going to be looking at our independent variable x, which is given by the depth underwater. We're also looking at our dependent variable y, which represents the total pressure. One other important piece of information is that we have a type of rate of 1 atmospheric pressure per 10 meters of depth. So we're going to see how we're going to incorporate that into our problem. We can also see below that they already modeled this data for us. They already collected it, put it in a table, and also put it in a graph. Now, we're going to start looking at problems 1, 2, and 3 below, but we're going to do them in a little bit of a different order. Let's go ahead and start with problem number 2. It says, what is the slope of the line? So let's go ahead and we can take a look at our graph to visualize and see what that's going to be. But something else that's also a little bit tricky is that we cannot really see how much we're moving too much by unless we look at our x and y axis. So looking at this, let's say we want to pick 2 pretty points on our line. So I'm going to pick this, my y-intercept, and I'm going to pick this endpoint here. And we're going to look at our slope. We're going to see how much do we move up and down by versus left and right. Because remember, when we're looking at slope of a line, slope stands for our change in y over change in x. We also know that is the same thing as our rise over our run. Here, we see that we rise 1 unit, going from 1 to 2, and then when we move over, we actually move over to the right in a positive direction 10 units. So our rise is 1 over 10. Now, another way that we can look at this is within our table. So let's say I wanted to look at the change in y. I would notice that each of my y values is actually increasing by 0.1. I'm adding that for every single value. Now, if I want to look at my x values, what they're going up by, I see that I'm adding 1 each time. So again, I could be adding 0.1 for my change in y. I'm adding 1 for my x. So we're probably trying to think, how am I able to show that same slope of 1 over 10 in the table as well? Well, actually, if we think about this, if we take our rise, so our change in y as 0.1, and we put it over 1, I will tell you that's another way to say 0.1. Now, 0.1, another way to say that is to change our decimal into a fraction, and lo and behold, we get the same thing as we did before. So we know that our slope is going to be 1/10, because usually we'll try to put our slope in terms of a fraction, and we don't really want to have a decimal within our fraction. So this question also still talks about what are the units of the slope. So on top that means what does our 1 stand for and what does our 10 stand for. The 1 actually stands for our pressure. And remember, our pressure is measured in ATM. So we could say pressure for the top. And for the bottom, the 10 represents the depth in meters underwater. So I'm going to go ahead and put depth for there. Remember, one last way that we could actually find the slope is to actually take the coordinates of our points on our graph, or we could take any 2 coordinates in our table. Let's just use the ones on the graph. So I have 0, 1, and I have 10, 2. And remember, we could use our formula of doing our y values on top subtracted by our x values. Remember, we could put our 1s first, or we could put our 2's first. It doesn't matter as long as we're labeling the points. So I have my x and y here. Let's label that as my first point. And then I have my x and y there, labeling as my second point. So if I put these into our formula, my y1 would be 1. I subtract 2. And on the bottom, I have 0 minus 10. If we keep working towards this, I can see that I'm going to get a -1 on top, a -10 on the bottom, which lo and behold reduces to 1/10. So again, we have the same slope as before. Let's go ahead and move on to our next problem. We're going to look at number 3 next. So it's asking for us, what is the y-intercept? So we can actually see this both on our graph and in our table. Remember, in our table, our y-intercept is when our x value equals 0. So it's actually the first point in our table. If we go to our graph, we can see that our y-intercept crosses right there. Now, to write down the coordinates of the y-intercept, remember, we want to write it as a point. So that means we want to write it as an x, y value. So we're going to write that as 0, 1. Now, it also asks for us to explain the meaning of this 0, 1 in the context. So remember, 0 stands for the depth underwater. So we can say at 0 meters underwater, we can say that the atmospheric pressure is at 1. So the atmospheric pressure is at 1. So we're saying before we even go into the water, above the water, there's some type of atmospheric pressure in the air, and it's at 1. Let's go ahead and move on to our last problem, number 1. So now it's asking us to write an equation that describes the relationship between the pressure exerted on a diver and the diver's depth of water. So we're really writing an equation for our table and our graph. So we know that our output, y, depends on our independent variable, which is x, our input. So think of how we start off with 1 initially. So even before going under any type of water, we have an atmospheric pressure of 1. That's our starting point. Then every time we go underneath a meter of water, we add 0.1 or 1/10 of the pressure. So remember, x stands for the meters underwater. So if I'm going 1 meter underwater, I'm really adding 1/10 to that. If I'm going 2 meters underwater, I'm going 2/10. I keep adding 1/10 over and over and over again. So the way that we could write that is 1/10 times x, because x represents our pressure underwater. Remember, we could also put this as a decimal. If you felt more comfortable writing instead of 1/10, we could also write 0.1. Either way works. Now, one last piece we want to include and keep in mind is that we technically don't even have to keep it in this same order. I could actually put my slope with my x variable first. So I could switch it around and rewrite this as 1/10 x plus 1. Or like I said, I could rewrite this as a decimal. So 0.1 x plus 1. Some of you may look at this and say, wait a minute, that equation looks familiar. It looks like y equals mx plus b. And guess what? It does look like that form. That's a throwback to last year, and that's what we're going to start talking about later on today. Hey, in fact, why don't we actually start talking about that right now? If you look below, some of you might have already seen, wait a minute, slope-intercept form of our linear equation is y equals mx plus b. Now, why do they call it slope-intercept? Well, remember, slope is your m. Your intercept, or y-intercept, is your b value. That's why this form is called slope-intercept, because we can easily see what the slope is and our y-intercept. And that's what it says below. M is our slope, that's the variable that we use, and b stands for the y-coordinate of our y-intercept. So this part right here is pretty important. That might be something really helpful if you want to stop right now, take a minute, and add that to the back of your spider, which is your word wall. Let's go ahead and start identifying the slope and y-intercept of a line given the equation in slope-intercept form. So, looking at number 4, we can see that we have this equation right here, and it really does model off of y equals mx plus b, where we're trying to identify what is our slope m and what is our y-intercept b. So, let's remember and remind ourselves that m stands for the slope and b stands for our y-intercept. So we want to figure out which numbers go with those. So if we look at the equation that we have written down in our general format with the one above, we can see that m lines up with -2. So that means our slope is -2. We can also see b lines up with 9. So our y-intercept will be 9. Remember, when we're looking at this, our slope, we could also write as -2/1 to represent the rise over run. And remember, our y-intercept, we can also write as the coordinate 0, 9. Let's try practicing a problem just like this off to the side. So let's go ahead, do a little small example off to the side. Let's say I give you the following equation, y equals 5x, let's try it again, y equals 5 minus 3x. I know I'm switching it up on you. I want you to go ahead and identify what the slope and y-intercept is. So pause the video right here, give it a chance to test it on out, and then come back and go over it together. All right, hopefully you didn't get tricked on this. Our slope this time is going to be -3 because remember, we're looking for the number in front of x. And our y-intercept is going to be 5. So remember, we could also write that as 0, 5. Let's go ahead and go on to our next page and look at example number 5. So let's zoom into that. So it's asking us to create a table of values for the following equation. So here's our equation. Y equals -2x plus 9. And then it wants us to plot the points and graph the line. So I'm going to do the first part with you in the table, and I'm going to have you practice plotting those points. So if we want to use our equation, that means if we're coming up with the x values, we are going to plug those values in for x in our equation to see if we can solve for y. That might require a little bit of work over in the margin right here. So if I'm plugging in -2 for x, that means I'm doing -2 times -2 plus 9. So -2 times -2, that's a +4. 4 plus 9, that's going to give me 13. Do you have to do the math in the margin? No, but sometimes showing that work does help prevent a lot of different errors. So let's try the next one. Let's plug in 0 for x. So I have -2 times 0 plus 9. So I have 0 plus 9, that's going to give me 9. Let's keep going. I'm going to plug in a +2 right now. So once I plug in +2, I end up getting a -2 times a +2 plus 9. So -4 plus 9, well, that's going to give me 5. And I want you to go ahead and try the last two on your own. Hopefully we'll pause the video right here and have you test them out, and then we'll check our answers. All right, if you check your answers, the last two, you should have gotten 1 and -1. So now we're going to go ahead and have you test out plotting these points on our graph. Remember, we're looking at our x-axis coming first. So remember, our x-axis is going to line up with our x-coordinates first. Then we have to plot our y-axis, which lines up with our y-coordinates. So go ahead, pause the video right here, and plot those 5 points. All right, you can go ahead and check your points with mine. I lined up the colors with each other. And sometimes if you accidentally plot a point in the wrong spot, we can double check by connecting all the points together. So we can connect the points, make a straight line, because our ultimate goal is to create that straight line. We know this is going to be a linear equation. We can also put arrows on the end, because just because our graph stops doesn't mean our line does. Let's go into our next question, number 6. So it's asking us to explain how to find the value of the slope from the table. Okay, so looking at this, the important part is it's from the table. Sure, could we find the slope from our graph? We totally could, but it wants us to look at how to do it from the table. So, do you remember how to do it from the table? I hope so. Remember, slope stands for our change in y over change in x. We could say that as rise over run. I'm writing both of these down, so we're familiar with both ways. Now, I'm going to show my work in a little bit of a different color, so that way hopefully it stands out a little bit. So in order to find our change in y, we're looking at to see what happens as we move from one y value to the other. We're also doing that with our x values, right? So with our y values, our change in y is I'm subtracting from my first y coordinate to my second one, I'm subtracting 4. Now, I got a little work that's in the way, so I think I'm going to erase a little bit of it, just so that way I have some space. You keep your work there, but you can see if you move around it, all right? So we're going to go ahead, and we can see that we're subtracting 4. Now, in our change in x values, we can see we're adding 2. So our slope is going to be negative 4 over 2. Now, maybe I can reduce that. Maybe I can find another way to write that. So let's keep going and testing if the slope is consistent, which it should be since we wrote this for the linear equation. So going from 9 to 5, we're subtracting 4. 0 to 2, we're adding 2. Again, it's the same thing. Negative 4 over 2 is our slope. If we keep going 5 to 1, we see, again, we're subtracting 4. Again, from 2 to 4, we're adding 2. We have that consistent slope across the board. Now, what if we switch it up? Look at this. When we go from 1 to negative 1, look what happens. We end up subtracting 2. And when we go from 4 to 5, we end up only adding 1. So think about this. Could we reduce our slope of negative 4 over 2? Yeah, we could. It's the same thing as negative 2 over 1, or we could just say negative 2. So we were able to find the value of our slope, but now we have to explain how we can find it from the table. Now, remember, another way that we could look at finding the slope and double checking it is with our equation above, right? We should get negative 2. But remember, the question is asking us to explain how to find the value of slope from the table. So let's start off saying that we looked at our change in y values and our change in x values. And we wrote the ratio of the change in y over the change in x. So let's say, look at 2 points. Like, let's say we're focusing on our first 2 points. We're going to say, find the change in y values and the change in x values. And then the last part is write as a ratio. Now, maybe some of you forgot what ratio is. Remember, that's just a fraction. We're having something on top as well as having something on bottom. Let's go ahead and start looking at number 7x. It wants us to explain how to find the y-intercept from the table. I think you got this. Go ahead and pause the video here and tell me how you can find the y-intercept from our table above. All right, so hopefully you were able to find out that our y-intercept is going to be 9, y equals 9, or you could have wrote the points 0, 9. So how do we figure out that from the table? Well, our goal is to find the point where x is equal to 0, right? Because that means that's where it crosses my y-axis. And then we look at that x coordinate. So find the point where x equals 0. Then look at the y coordinate. May have said x before, I apologize for that. But we know x is 0, then we figure out what the y coordinate is. Let's go ahead and go on to our next question. Ooh, I think we're going to like this next one, number 8. It says, explain how to find the slope of a line from the graph. Oh, how to find the value of the slope from the graph. Then it's asking what the slope is. All right, you totally got this. Find the slope of this line and write your explanation for how you can find it from the graph. All right, hopefully you were able to see and verify that the slope is negative 2. Now, our explanation could be that we can pick 2 points. So we're going to pick 2 points And remember, I always try to say pretty points, right? That means ones that have some nice whole numbers. So pick 2 points and find the rise over run between them. It's a lot easier when we do have our visual to be able to find the slope. All right, let's go to the last one on this page. Number 9 says, explain how to find the y-intercept from the graph. All right, go ahead, find out what the y-intercept is. All right, as you can see, it should be 9, or again, if you want to put the 0.09. Remember, we can look at our graph and visually see that it's the point that crosses our y-axis. So that would probably be my explanation that I would write. We could say it's the point that crosses the y-axis. Now, you're probably looking at all these questions and thinking, wait a minute, weren't we kind of assessed on slope already? Exactly. Our last unit, we're really building off of it. We're now pulling in that y-intercept aspect. We're making a table, doing a graph, and also working with our equation in slope-intercept form. Now, that's where we're going to stop for today's lesson. Tomorrow, we're going to do a little bit more practice of this in class. So enjoy the rest of your day.